Hello class, let's take a look at example 2, and this is the basic idea. They want us to actually estimate the parameter of the mean. And within the parameter of the mean, you're given the sigmas known. So all of our actual critical values are going to be z-scores. So you're going to have basically the previous sketch, and you're looking at the following. This is going to be a bell-shaped curve, and this is going to be a z-score on the left, a z-score on the right. This one's going to be a critical value. And then what we have here is that z is equal to 0.95. Therefore, alpha happens to be 0.5 because remember that the total area under the curve is equal to 1. So this means that in each of the tails, you're going to have 0.025 area. That means that this area here is going to be 0.025. This area there is also going to be 0.025, which is equal to alpha divided by 2. So the symbol here that we're using is alpha. Let me fix it. Now, what we're going to be doing here, it's actually getting the critical value on the left. And let me just put, well, technically c is equal to 0.95 there. To find this critical value, you're going to be using the inverse code. And let me give you the code. The code is going to be inverse norm with 0.025, 0, and 1. That's the code that will give you this critical value. Please run it. I'm getting negative 1.96, rounding to 2 decimal places. The one on the right is going to be 1.96. So the critical value is going to be c, which is approximately 1.96. Your critical value, it's always going to be the z-score on the actual right. Yet again, to find it, we first found the one on the left. Now, this specific critical value or z-score, it's going to be used in a formula to estimate the parameter.